We've all heard it, right? In this age of AI, data is the new gold. But what happens when all that gold gets stuck in a massive digital traffic jam? Well, today, we're diving into a critical problem that's slowing AI down, the data bottleneck. And we're going to look at the powerful toolkit, Nvidia Rapids, that's designed to blow right through it. So let's get right into it. Picture this. You can have the most sophisticated AI model in the world, running on the absolute best hardware money can buy. And yet, your progress is just painfully slow. The culprit usually isn't the model itself. It's something much sneakier, a hidden bottleneck in your data pipeline. And this quote just captures the whole problem perfectly. Data is the fuel for AI, no doubt. But getting that fuel into the engine fast enough, that's the real challenge. Your most powerful models are completely useless if they're just sitting around, twiddling their digital thumbs, waiting for data. So here's the deal. The bottleneck happens when your super fast GPU, the real workhorse of AI, is left waiting. And what's it waiting for? It's waiting for the much slower CPU to finish all the prep work, all the cleaning, transforming, and transferring of data. That CPU pre-processing, it becomes the single biggest drag on the entire system's performance. Let's take a look at a typical data pipeline to see what I mean. First, you ingest the data. Then it goes through a whole bunch of steps on the CPU, cleaning it up, engineering new features, transforming it, often with tools like Pandas or Numpy. It's only after all that slow, step-by-step work is done that the data finally gets handed off to the GPU for the actual training. See how much of this process is stuck on the CPU? And that right there is the heart of the problem. This old-school CPU-bound process creates a massive digital traffic jam. Your model is revved up and ready to go, your GPU is primed for action, but everything is stuck in gridlock, just waiting for the CPU to finish its work. But what if you could just bypass that traffic jam completely? What if, instead, you could build a data superhighway that operates at the insane speeds of a GPU, from start to finish? Well, this is exactly where Nvidia Rapids comes into the picture. And it's not just one tool. It's a whole suite of software libraries designed to let you run the entire data science pipeline, end-to-end, directly on the GPU. Now, Rapids isn't some brand new thing. Nvidia launched it way back in 2018 to specifically solve this bottleneck problem. But its popularity has just exploded, and for a good reason. It gives you the high-performance data pipelines that today's AI models are starving for, and this is the best part. It uses a familiar programming style that's super easy to pick up. The approach here is a complete game changer. Instead of constantly shuttling data back and forth between the slow CPU and the fast GPU, Rapids just keeps it all in the GPU's ultra-fast memory, the VRAM, for the entire process. Every single step, loading, cleaning, filtering, it all runs on thousands of parallel GPU threads. The CPU bottleneck, it's just gone. Okay, so what's actually inside this toolkit? For anyone who's a data scientist, a lot of these names are going to sound really familiar, and that's actually key to why Rapids is so powerful and easy to adopt. First up is cuDF. The easiest way to think about this is it's basically Pandas, which is the go-to library for working with tables of data, but it runs on your GPU. The big difference? The performance gains are just staggering. I'm talking about tasks that used to take hours on a CPU, now finishing up in minutes, or sometimes even seconds. Then you've got cuML, which is inspired by the super popular Scikit-learn library. It gives you GPU-accelerated versions of all the classic machine learning algorithms for things like regression, classification, and clustering. Honestly, it's one of the fastest libraries of its kind out there. And the ecosystem just keeps going. There are tools like cuGraph for network analysis, cuSpatial if you're working with maps and location data, and even Blazing SQL for running SQL queries directly on the GPU. It really is a complete suite for pretty much any data-heavy job you can think of. All right, this all sounds really impressive in theory, but how does it actually hold up in the real world? Let's look at a practical example just to see the kind of dramatic performance gains we're talking about. So our test case is a very common but very data-intensive challenge: detecting fraudulent credit card transactions. This means we have to create a bunch of features from raw data and then train a model, all on a pretty large data set. And we're not talking about a small sample here. The script we're looking at generates and processes 50,000 synthetic transactions, creating 13 different features from that data before it even starts training the fraud detection model. This quote from the source material just perfectly captures the result. The entire pipeline, from generating data to engineering features to training the model, it all ran so incredibly fast on the GPU with Rapids that it barely even made a blip on the usage monitor. It's just that fast. The impact here is crystal clear. We're talking about going from a workflow that could take you hours on a CPU to one that's finished in a matter of seconds on a GPU. This is way more than just a simple improvement. It's a fundamental transformation of how you can work. So, what does this incredible speed up really mean? It's about so much more than just saving time. It's about unlocking the potential to ask bigger questions, to analyze massive data sets, and to innovate at a pace that just wasn't possible before. So let's quickly recap the main points. First, the data bottleneck is a very real and very serious limit on AI progress. Second, Nvidia Rapids smashes through that barrier by moving the entire data pipeline onto the GPU. The result is a massive, almost unbelievable reduction in processing time. And finally, because the tools use familiar APIs, they're incredibly easy for developers to start using. And this brings us to a final, really exciting thought. For years, the speed of AI innovation has been held back by how fast we can process data. But now that data can finally keep up with our most advanced models, we can accelerate research, we can do real-time analysis on huge datasets, and we can build more complex things like the massive RAG pipelines that power so much of modern AI. The question isn't how we'll process the data anymore. The question is, what will we achieve next?